Okay, so today we're going to look at graphing and writing inequalities. So to warm up, let's review what we already know. So for number one, we need to look and see if -3 is less than, greater than, or equal to 2. Well, we know that negative numbers are always less than positive numbers. So -3 is going to be less than 2. Okay, for number two, 6.5 and 6.3. So 6.5 should be greater than 6.3. For number three, is 1/2 greater than, less than, or equal to -3/4? Well, again, we have a negative number, so we know that that negative number is going to be less than that positive number. And finally, for number four, 0.25 and 1/4. Well, what is 1/4 as a decimal? We should know that 1/4 is equal to 2.5. So therefore, these are equal. Okay, so now we're going to tell whether the inequality of x is less than 5 is true or false for the following values of x. So we're going to plug in the values of x into the inequality. So x equals -10. Well, let's plug that into our inequality. And let's check, is -10 less than 5? It is, so this is true. For number 6, x equals 5. Let's plug 5 into our inequality. Is 5 less than 5? No, those are equal, so this is a false solution. For x equals 4.99, if we plug that into our inequality, is 4.99 less than 5? Yes, so this is a true statement. Let me fix my T up here. Okay, for number 8, x equals -1/5. So let's plug -1/5 into our inequality. Make that less than, sorry about that. Is -1/5 less than 5? Well, we know that 1/5 is less than 5, but it's also a negative number, so it is true as well. Okay. So we want to make sure that we understand things when they're written in words to convert them into mathematical equations. So what are other ways that we can say there are fewer than 20 students in success training? Or how about the high temperature will be at least 70 degrees tomorrow? Well, let's look at using words. Today we're going to identify solutions of inequalities with one variable, and we're also going to write and graph inequalities with one variable. So you should recognize the vocabulary of an inequality and then the solution of an inequality by the time we're done with this lecture. Okay, so an inequality is just a statement that two quantities are not equal. The quantities are compared by using the following signs. So we know that we use the less than sign to say that something is less than something else. That's not supposed to be equal, then ignore that. So A is less than B, so we write the little alligator eating thing, however you guys want to call it. It is eating B because B is greater than A, or A is less than B. If we want to say A is greater than B, then the little crocodile is going to eat A. If we want something to be A is less than or equal to B, then we want to point the inequality sign toward B, but this time we have a line under it to represent that it's also equal to. If A is greater than or equal to B, then the inequality sign is facing towards A. And finally, to say that something is not equal, we just use an equal sign with a slash through it. And then a solution of an inequality is just any value of the variable that makes the inequality true. So basically, whatever I can plug into the variable, be that x or whatever, if I plug it in and the inequality is still true, then that is a solution of the inequality. Okay, so we're going to check to see if some of these values are solutions of the inequality. So we're given the inequality x minus 6 is greater than or equal to 4. And our values of x are given to us right up here in the top of the chart. So we're going to plug those into the left side of the inequality, x minus 6. So we're going to plug in -3 into x and get -3 minus 6, which we know is -9. So is -9 greater than or equal to 4? No, it is not. So this is not a solution. Let's plug in our 0. 0 minus 6. Well, 0 minus 6 should come out to negative 6. Is negative 6 greater than or equal to 4? No. So this is not a solution either. Okay, let's try our next one. 9.9 minus 6. 9.9 minus 6, you should get 3.9. Is 3.9 greater than or equal to 4? No. So 9.9 is not a solution either. All right, let's plug 10 in. 10 minus 6. 10 minus 6 is 4. Is 4 greater than or equal to 4? Yes, we know that 4 is actually equal to 4, so this is a solution. Okay, now let's plug in 10.1 minus 6, and that should come out to 4.1, which we know is greater than or equal to 4, so this is a solution. Now let's finally plug in 12 minus 6, and we're going to get 6 out. 6 is also greater than or equal to 4. Okay, so basically we figured out that if x is less than 10, so let's write that down. If x is less than 10, then we know that x minus 6 is less than 4. No, that is less than 4. So any number that we plugged in for x that was less than 10, it made x minus 6 less than 4. So that didn't work out. When we plugged in x equals 10, so any number exactly at 10, then x minus 6 is equal to 4. And finally, when x is greater than 10, we would get that x minus 6 is greater than 4. So basically any number 10 or above, when we plugged it into x, it satisfied the inequality. So it appears that the solution is that x is all real numbers greater than or equal to 10. Okay, so on to the next slide. Okay, so now we're going to look at how we graph inequalities. So the inequality that we're given is 3 plus x is less than 9. So it's kind of hard to list all the solutions that will satisfy this, so most of the time we'll end up graphing it, and we can use a graph on a number line to show the solutions. Okay, so what numbers can we plug into x that will still get something less than 9 on that left side? So we can just arbitrarily pick a number. So if I plug in 1 here, I'll get 3 plus 1 will be 4. Okay, that works. That's less than 9. So let's try something else. Let's plug in 2. If I plug in 2, I'll get 5. That's still less than 9. If we keep going and going, we can go all the way up to basically 5.999999 repeating, because if we add 6 into x, we're going to get 9, and we know that 9 is not less than 9. Okay, so it's basically every number that is less than 6 will work, but we don't want to include 6 on this. So what we do is we draw an open circle at 6 to say we're not including 6, but we're going to then color in our line to say it's everything less than 6. Okay, so everything less than 6, all the numbers before 6 will satisfy that inequality. Okay, so again, we use the open circle for a less than or greater than sign. We'll see on the next one that we're going to use a closed circle, meaning we'll color it in if you see a less than or equal to or greater than or equal to sign. Okay, so here's just some examples. So if x is less than 5, they're showing you that they're using an open circle at 5, and then it's all the numbers less than 5. If x is greater than -1, You're going to look at -1, and we're using an open circle again because it's not greater than or equal to. And then it's saying it's everything bigger than that. So we're going to color in everything to the right of that number. For all the real numbers that are less than or equal to 1/2, we're going to find 1/2. And since this time it's the less than or equals than symbol, we are coloring or making a closed circle at 1/2. And it's telling us that x is less than or equal to that. So it's everything to the left, because remember the number line, if we go to the left, things are getting smaller. And finally, x is greater than or equal to 0. We draw a closed circle at 0 and color in everything to the right because it's greater than. Okay, so now we're going to try to graph these inequalities. Well, we've got m is greater than or equals to 3/4. So you should see right off the bat that since it's greater than or equals to, you're going to use a closed circle. So we're going to find 3/4 and we're going to do a closed circle. Now, do we go to the left or the right? Well, if m is greater than or equal to 3/4, it's going to be all the numbers bigger than that. So we're going to color in a solid line. Sorry, my little solid circle got lost, so I'll make that bigger. Okay, for t is less than 5 times -1 plus 3. Okay, we can't actually do this one until we carry out the right side of the equation, the inequality. So we need to simplify this first. So we need to combine like terms. So -1 and 3, you should get 2. Now, 5 times 2 is 10. So here's our inequality. T is less than 10. Okay, so we're going to find 10. Now, we need to do a open circle because it's just the less than sign. It's not a less than or equal to. So we're not including 10. And it says it's everything less than 10. So we're going to go to the left. Let's see if I can color it. Everything to the left. So all the numbers to the left of 10 will work for this. Okay, so now let's see if we can write an inequality if we're given a graph. And make sure if I'm going too fast, you guys just pause this video at any time and try to stop and do the problems on your own, okay? All right, so let's find where our circle is. Well, we see that our circle is at 2. So we know that 2 is going to be somewhere in the inequality. And we see an open circle. So we know that it's going to be a greater than or less than sign, but it's not going to be the greater than or equal to or less than or equal to sign. Okay, and it's colored, we're coloring everything to the left. So we know all these numbers to the left of 2 are less than 2. Therefore, we're going to say that 2 is less than, and you can pick whatever variable you want. We can just do x. So, or you can read it as x is greater, or actually, ignore that. Sorry. We're saying that x is everything less than 2. I meant to do it that way. Sorry about that. Ignore this up here. Okay, because the little crocodile guy is eating the 2, meaning that the 2 is bigger than x, and that all the values now are everything less than 2. Okay, you could also write this way, as long as the little crocodile guy is facing the 2, because we're saying that x is less than 2. Okay, for this one, let's find our value where the circle is. So we're at -0.5. So at -0.5, we are coloring all the numbers that are to the right of it. So that means it's everything bigger. So all our values of x are going to be bigger than this. However, if you noticed, it's a closed circle, so we need to draw a greater than or equals to sign. So we may have to make sure that we have that line underneath to include -0.5. So again, x is all the numbers greater than or equal to -0.5. Okay, make sure that you know that if a word problem says no more than, that means the same thing as less than or equal to. And if you see the words at least, that means that we're talking about something that's greater than or equal to. Okay, so we're going to come across those in this last word problem. Okay, so it says that Ray's dad told him not to turn on the air conditioner unless the temperature is at least 85 degrees Fahrenheit. Define a variable and write an inequality for the temperatures at which Ray can turn on the air conditioner. So we know that we get yelled at sometimes when we turn on the air conditioner because our parents want to save money and electricity. So Ray is being told that he can't turn on the air conditioning unless it is 85 degrees or hotter. So we're going to let T represent the temperature at which we can turn on the air conditioning. And so our verbal model says that we can turn on the air conditioning when the temperature is at least 85 degrees Fahrenheit. Okay, well, we already said that we're going to let T represent the temperature. So we're going to plug in T there. Now we know that the words is at least from our last slide, is at least means that it's greater than or equal to. So T is going to be greater than or equal to, and then we can just put 85. So if we write that a little closer together, T is greater than or equal to 85. Now all we have to do is graph it. Well, at 85, we are going to use a what kind of circle? It's going to be a closed circle because we're including 85. And it's telling us that T is everything greater than or equal to it. So it's everything over to the right side, all the numbers on this side. Okay? All right. Well, that is it. So make sure you understand the graphing, the inequalities, and how to check if it's a solution. And that is all.